was your break?
It was pretty good. Had a lot of food.
Okay, guys. So today in class we're going to be talking about an experiment that demonstrates the principles of heat transfer. It's pretty important for chemical engineers, and it may seem pretty complicated at first, but ironing on a design t-shirt is pretty simple. So lots of your t-shirts have designs on them, like this one. And it's important for us to learn how these everyday things were made. So hopefully this experiment will get you guys super excited about chemical engineering like me. And as you start thinking more about chemie, I hope you'll see that a lot of things you do in your everyday life are related to chemical engineering. This experiment is super simple for all of you guys to participate. So you'll each get to design your own t-shirt. How exciting is that?
What?
And best of all, the materials needed to perform this experiment cost less than $25, so you can do it at home again and again. Alright, so let's get started. First, we're going to go over all the materials you need to do this experiment.
1 iron. 1 or more t-shirts.
Iron-on patches of your choice.
A towel or cloth.
And an ironing board or table.
So now that we have the materials, what do we do next?
Great question. So first, set up your flat surface. Good. Now put your t-shirt on the flat surface. But maybe make sure it's flat so we can iron onto it. Good. Next, you can take a patch, we'll use this one for now, and cut it out and then place it where you want it to be. Make sure that's also flat and straight.
Like that?
Yeah, good job. And you also might have to put a towel on, not for these because they have a protective backing, but just in case you do it again at home. I know you're really excited. And now we have to set our iron. So this shirt is cotton, so we have to set it to about 400 degrees Fahrenheit, and it'll depend on the shirt, what temperature you set it to.
So I've never had to iron anything before. Do I just like...
No, don't grab it like that. You can't grab the iron at the hot part. You'll burn yourself. I know this experiment requires extreme caution. Please be careful, guys.
Great tip. I don't want to burn my hands before I use them.
Exactly. So once the iron is set at necessary temperature, place it on top of the area with the iron-on patch and apply pressure for about 20 seconds. Now allow the patch to cool for about 15 to 20 seconds. Double check to see if the patch has been successfully attached to the t-shirt by rubbing your finger along the edges while gently lifting up on the patch.
Wow! Now my t-shirt is so much cooler! But wait, how'd this work?
Hi guys, I'm Mr. Chemical Engineer and I'm going to explain to you about how this whole thing works. So the patch is ironed on through heat transfer through conduction. Conduction occurs when molecules bump into each other and transfer energy from a molecule of high energy to a molecule of lower energy. This type of conduction occurs in series because the heat energy is transferred through layers of the material. So on the side of the patch that's in contact with the t-shirt, there's an adhesive. This adhesive is called a hot melt adhesive. So when the heat goes all the way through the patch and it reaches a certain temperature, that adhesive is going to melt. When it melts, the hot melt kind of acts like spaghetti. So these polymer strands in the hot melt kind of entangle between the strands of the fibers in your t-shirt. So you get like a tangling spaghetti almost effect. And then when you remove the iron, that cools, that forms a very solid, stiff structure, and that's what sticks the patch to the t-shirt.
And those principles let us make this awesome t-shirt?
Yeah, because chemistry really does rock. Chemical engineers can do some pretty neat things.
Chemical engineering may sound pretty complicated or intimidating, but really there are 3 main paths chemical engineers will take to solve real-world problems. The first is medical and pharmaceuticals. This involves developing and improving the process of medicine production. Some of the medication you take could be the work of a chemie.
The second path is the oil and gas industry. Besides fueling the buses and cars you take to school, chemical engineers in this industry develop fuels to do anything from make clothes to form new plastic and water bottles.
The third pathway typically taken by chemical engineers is working in consumer products. You know, Scotch tape and Pillsbury cookies. These were both products of chemical engineering.
And all these jobs use principles that we learned about through iron-on designs. That's the cool thing about chemie is you can use it in so many different ways.
Wow, chemical engineering really does rock. Chemie rocks!
box.